Hello everyone. In this video I'm going to continue to talk about angles property in a circle. Before we continue to talk about that, I would like to introduce to you a new term, cyclic quadrilaterals. Cyclic quadrilaterals that are quadrilaterals that there exists circle which passes through all vertices of that quadrilateral. See the example below. There are two quadrilaterals, but then this figure, the circle can only be drawn through three of the vertices, and it cannot be passes through the fourth vertex. And in this case, we cannot call the quadrilateral a cyclic quadrilateral. But the figure on the right, you see that all four vertices are lying on a circle. And in this case, that quadrilateral, we call it the cyclic quadrilateral. And we are going to talk about angles property of cyclic quadrilaterals. If there are 4 points A, B, C, and D that are lying on the circumference of the circle, then we have the angle properties as follows. I assume the angles here is A and the angles here is C. We will have the sum of the opposite angles being 180 degrees. Why? Because if we extend B and D to the center of the circle O, then we can make use of angle at center twice angle at circumference to say that the angle Boyle dot is actually 2 times C. And on the other hand, when this angle is A, we can have the angle here 2A. Then we know that 2A and 2C, the sum is 360 degrees. And thus, the sum of A and C must be 180 degrees. The same thing also happened to these two. When I call this angle D and the angle here is Boy, by similar arguments we can also have Boy plus dot equals 180 degrees. In using this kind of thing, we need to quote this reference, opposite angles cyclic quadrilateral. Similarly, when we have opposite angles cyclic quadrilateral, we can also have something like this. Okay, when the circle, when there are 4 points A, B, C, D lying on the circumference of a circle, and there is an outside point E, so that A Boy E is a straight line. Then we first know that if this is angle B, this is angle D, the sum of Boy and dot is 180 degrees, right? And if I mark it as angle E, by adjacent angles on straight line, we also have E plus dot equals 180 degrees. And comparing these two, we can have Boy equal E. So an interior angle in a cyclic quadrilateral would be equal to an exterior angle of the cyclic quadrilateral. You just need to remember the position. The angle, interior angle here, the exterior angle would be the opposite of this angle, and the exterior is next to the opposite of this interior angle. And once when you want to conclude these two angles being equal, you need to quote the reference, exterior angle cyclic quad. Okay, so in doing this kind of questions, you need to note that there are at least 4 points in lying on the circle. And in particular, for this kind of reference, you need to have some extension of side. Okay, so that's all for the introduction of the angles property in the circle, and there are some more examples coming up. Okay, thanks for watching.